Hello, everybody. This is a great honor to speak here at S4 conference. Thank you for inviting me. And today I would like to start my talk about Hello World. What do I do? What do I like? My career started as a penetration tester. So basically what I do is pen testing. This is an awesome thing. It always brings you really nice and interesting challenges. I also do the industrial control system security research, SCADA security research, and I love CTF challenges. I used to play CTF challenges a lot, and right now we're organizing our CTF challenges, also the industrial control system related CTF challenges. But today I would like to talk to you about the encryption algorithms in industrial control systems. Everybody knows that encryption is really important. It's an obvious thing, but some companies, they try to implement custom-made encryption algorithms, and sometimes they misunderstand encryption and with something really strange. And today I would like to bring, I brought you some examples, real case examples, what we have met during our research work. And I would like to discuss with you what is the possible damage of using self-made encryption algorithms in industrial control systems. So what are the good things about encryption, especially in ICS field? The first thing, of course, is confidentiality. So every time when you send a sensitive, especially sensitive information somewhere, you always sure that nobody will get this information except a right person. You always know from who you receive the information. So you are sure that you got this message, this information from a right person. And you are sure that during the transmission the information wasn't changed. There are also several bad things about encryption in industrial control systems. So every time when you go to the industry guys who runs like the factory, and you offer them like, hey, let's deploy some kind of encryption in your networks, they always say that, well, you know, that's not actually a real-time thing. It is really important to keep on your mind that most of the industrial control systems, they are real-time. They work with the real-time data, and every time when you deploy something new, something encryption related, it could be possibly a new point of failure, and it actually sometimes it doesn't meet any reliability requirements, and that's why some of the industry guys, they just do not trust it. And they always say that, hey, our network is disconnected from the global internets, so we actually do not need to use any encryption. And for some reason, for several people, the encryption is too complicated. That's funny, but well, it happens, and I will show you the example. So, and this brings us to the really strange things about encryption and using the different algorithms in industrial control systems. So, let's start with the examples. By the way, I will try to avoid, I will not name any companies because, well, for most of the vulnerabilities, there are already patches. But most of the companies, the industrial companies, when you inform them, when you say them, hey guys, you got vulnerabilities and you have to deploy this patch, they say, well, you know what, we actually have we plan to renew our system in 2020, so let's wait till that time. and that's quite strange. So yeah, weak encryption algorithm in one SCADA. This is actually a bit typical example of how the algorithms are being deployed and used in the SCADAs. So the encrypted login and password are stored in the files, just one simple file. Basically, it uses only 32 bytes for password, and every time when you input your password, for some reason, the password goes always to uppercase. So if you, for example, use different cases like lowercase and uppercase, it will be always in the uppercase. So if the attacker, the potential attacker, wants to brute force the password, it will be much easier to do. The maximum length for login is 20 symbols and for password is 15 symbols. But if you use like a shorter password or shorter login, the mechanism always inputs some like encrypted symbols on the rest of the field. And the funny thing that there are two functions, encode pass and decode pass. So basically, to decrypt the password, you just have to call the decode pass function, and that's it, you're done. The next example. It is pretty similar to the previous one. The logins and passwords are stored in the registry. Yeah, it also has the getAdmin account info function. So basically, you just have to call it, and that's it. But the other interesting thing about this algorithm is that, so we decided to take a look on the official documentation from the vendor, and we have found really interesting thing. So the vendor says that you have to input login and password with admin privileges into your SCADA. The next step is that you have to use the same login and password on all the network components in your internal network. And the last step is that all the logins should be with administrative privileges in all the network. So, for example, if you deploy like the SCADA like in a really huge factory, everywhere will be the same login and password according to this documentation. And all these logins supposed to be the administrative login and password. So this is quite interesting from the pen testing point of view. This is actually an easy way to exploit the whole factory. The other example is brings us to the real critical infrastructure. The vulnerability was found in the PLC, which has been using like in the critical infrastructure. We have found that the passwords supposed to be only 8 numbers, just no letters, just like numerics. So that was a really interesting case, and we decided to take a look on it. So let me provide you the example how it works. So it is working with a built-in encryption key. So let's say that the built-in encryption key is a cucumber, and if you input the password with 8 zeros, the decoded password is supposed to be the cucumber. If you will input the password with 8 ones, so it will be like DVD and VNCFS. So, do you know what is it? Do you know this guy? It's a Caesar. So it's a Caesar encryption, like it's a custom version of Caesar encryption algorithm. Basically, it is implemented for each position, and you have to shift. The number according, not number, but the letter according to your built-in encryption key. And if you use, for example, the password less than 8 numbers, the rest of the spaces are being replaced with the zeros. Well, that is actually a really interesting example. But the weakest encryption algorithm that we have seen. Let me give you an example. Yes, I have finally found the XOR algorithm. So during my whole working experience, I was wondering if it is still possible to find the XOR encryption algorithms on the real devices, on the real SCADA systems. Yes, and I finally found it. And during that research, the bonus thing was that I have found the best implementation of denial of service of the whole PLC. Basically, when you exploit that vulnerability, you cannot reboot the PLC remotely. You just have to walk to the PLC, unplug it unplug the power cord and plug it in again, and only in this case it will start working again. So yeah, I just made a screenshot. Yeah, I used the super hacker password 1337, and it was XORed. So yeah, and you can easily see it in the network traffic. The other thing is that this vulnerability allows also not to sniff the passwords, but also to change the passwords and to send remote commands to the PLC without having any privileges. And talking about the denial of service vulnerability, well, this is actually really funny. Every time when you open the connection to a remote port, to the controller, that's it, the controller is dead. So you cannot do any maintenance, you cannot send any commands to the controller. So you just have to use the netcat utility, and the denial of service is working. And we have created the vulnerability report to the vendor. We always do that, and so I contacted to the official person. So, and I said hey, we would like to tell you about the vulnerabilities that we have found in your solutions. There was a manager guy, the technical manager guy, and he basically said that well, I will not be able to open any attachments that are not Microsoft Office or Adobe PDF. Well, that is actually interesting thing, because, well, the statistics says that most of the exploits in the wild are being used especially in the Microsoft Office and the Adobe PDF files. So I insisted that you have to use the proper encryption to get the vulnerability reports, because the vulnerability information it's quite sensitive data, and well, you have to take care of it. Well, the answer was actually amazing. He said, Vladimir, a direct email from you to me is secure enough. Well, I don't know, this person probably thought that it's quite like point-to-point encryption, I don't know. Well, yeah, that was my reaction. And this is basically all the examples that I wanted to share with you. And about the conclusion, I would like to say that sometimes when you implement the encryption, some custom-made encryption algorithm, it doesn't mean that it is secured. You have to use the already known encryption algorithms and methods to make your solution secured. And encryption is a really awesome thing. You have to use it properly. And we work really closely with several companies, the vendors. And most of them really awesome persons, and they react on the vulnerability details really good. So, but some of the vendors, they do not do this, and that's, I don't know why. So if a company doesn't want to patch it, you have to patch it. And talking about the previous example with that funny report, we had to contact to the US ICS CERT. We sent them the information and we asked to help us because, well, we didn't find any solution how to mitigate that problem, and only US CERT helped us to solve it. So if you have any questions, I will be happy to answer it. Thank you.
Hi, Lucian Constantin from the IDG News Service. I wanted to ask, because I saw your examples mostly covered encryption to store passwords. Why would you use encryption to store passwords and not hashing?
Well, this is actually a really good question. I don't know why they do not use the hashing algorithms to store passwords. Well, most of the solutions, they use the proper algorithms. So they use the hash algorithms, and then, well, they use hash algorithms. But in these examples, I don't know why they use like the encrypted version of the password. So.
Other questions? You know, in general, whenever you hear proprietary encryption or proprietary security algorithms, it's usually a good time to run away.
Oh yes.
Because it's very, very hard to do well. We even see implementations of vetted algorithms. It's hard even to implement vetted algorithms without causing a problem. You mentioned at the beginning, you mentioned that some of these people had provided patches.
Right.
So like the example you gave where the same username and password had to be used everywhere in the network. Is
Right.
that something that they actually were able to patch?
Well, talking about that vulnerability, the vendor asked us more than a year to patch it. So they have to rebuild like a lot of systems. They have to write a new code to create a new way of securing the solutions. So they still working on the patch to secure the systems, but some of our customers are using that solution, and we are scared that they will not deploy the proper patch. They will not reinstall their systems until 2020s.